All right, happy Monday, everybody. Today's shout out is going to go to, Elias for introducing us to a great book last week, Make Your Bed. Mrs. Remsen's already ordered hers on Amazon. It's very inspirational. You should check it out. It's called Make Your Bed. Today's goal is that you can factor trinomials when A is greater than 1. So let's get started. So last week we were factoring trinomials, but all of the trinomials that we asked you to factor last week happened to have an A that was 1. And you'll see what makes the other ones different today. But for example, last week you could have been factoring a problem such as this: x squared plus 8x plus 15. And to factor that, you would have made your little puzzle, your little x puzzle. We're looking for two numbers that multiply to give you 15 and add to give you 8. Those two numbers would be 3 and 5. So your two parentheses would be x plus 3 and x plus 5. So the two binomials that this trinomial factors into is x plus 3 and x plus 5. If you then needed to solve it, you could make this equal 0 and then write each equation, each separate factor equals 0, and solve to get the two solutions, roots, or zeros, which in this case would be -3 and -5. So today we're going to go over what you do when you have an A that is not 1. It's a little trickier, but you can do it. We're going to show you two ways. There are a few ways, and some of you might know other ways of doing this. But the most common way, and the way that you'll see other teachers doing this at the high school, is called the split method, or sometimes they call it the grouping method. This is the most common way because as you get to longer and longer polynomials, you can still use this grouping method. I'm also going to show you another method called the lazy AC method, which a lot of you will probably like because you're lazy. So we're going to start. Here's one that's done out for you. I'm going to start with the other examples, and then you can refer back to this one and go on Flipgrid and see some other ones done out. So if we start with the first try, I'm going to do this first trinomial, factoring it using the split method. So the split method says you still start with your little number puzzle, but instead of putting 2 here and -13 here, we're actually going to multiply A times C. A times C is what goes in the top of your puzzle. That's what went in the top of your puzzle last week, but your A happened to be 1. So you were actually using this method last week. Our bottom number is -13 because that's our B. So we want two numbers that will multiply to give us 12 and add to give us -13. So those two numbers would be -12 and -1. If you add them together, you get -13, and if you multiply them, you get +12. So now that part was the same as what you did last week, but here's where it gets different. To use the grouping or split method, you take your trinomial and you write it over. So I'm going to start writing 6s squared. But instead of writing our middle term, we're going to change the -13s into a -12s and a -1s. We're going to use the two numbers we found in our puzzle to replace that middle term. And then we're going to keep our C the way it was. So now instead of having a trinomial, we have a polynomial with 4 terms. So some of you might think this method is crazy, but what you can do from this point is split it down the middle, which is why it's sometimes called the split method. And on each side, we're going to take out a GCF. The GCF on this side will be 6s. I'm going to write my parentheses to say what I would have to multiply 6s by to get back to the original, and I would have to multiply it by s minus 2. I'm going to take this s minus 2, this parentheses has to match over here. So I know over here, when I'm done taking out a GCF, I want to be able to get s minus 2. So if I look at what I have here, in order for this to give me s minus 2, I would have to take out the negative. So I would have negative 1 as the GCF of these two. So once you split, you take a GCF on each side. The GCF is then written with the parentheses. If you do it correctly, your two parentheses should match. So if these two didn't match, I would be wrong. Now my answer is going to be the parentheses, so s minus 2, and then my other parentheses is going to be the two GCFs, 6s minus 1. This is the factored form of 6s squared minus 13s plus 2. If I multiply this times this, I will get this. This is called the split or grouping method. So we're going to try the split or grouping method again, and then I'll go back and do these with the lazy method. So to start this one, I'm looking for two numbers that will multiply to give me negative 2 and add to give me 1. So if they're multiplying to give me a negative, I know one is going to be negative and one will be positive. I have a positive sum, so the larger one has to be positive. So it's going to be positive 2 and negative 1 that work. Once I have my two numbers, I take my trinomial and rewrite it so it has 4 terms, replacing the middle b with a negative b and a positive 2b. And I'm going to keep my c the same. Once I have 4 terms, I'm going to split down the middle. On each side, I'm going to take out my GCF. So my GCF over here would be just b, because there's no numbers in common, it's just the b in common. And then my parentheses would be 2b minus 1. If I multiply this out, I would get back to this. On this side, I'm going to take out my GCF, and so 2b and negative 1 have nothing in common. So their GCF is actually just the number 1. That's the only thing that would go into both evenly. So the parentheses would be 2b minus 1. So now to write my solution is the GCFs make up one parenthesis, so I'm going to write b plus 1. And then my other parentheses would be 2b minus 1. Now, if you had switched these two terms and decided to write plus 2b and then minus b, you would still get the same exact answer. So if you were starting to set it up that way and then switched it because I didn't, it doesn't matter, because now I have this 4-term polynomial that I'll split. And now on this side, I do have a GCF. My GCF is 2b. My parentheses would be b plus 1. Over here, I'm going to take out negative 1. And my parentheses would be b plus 1. So I get the same parentheses for my final answer. I'm just getting them in a different order, and the order doesn't matter because it's multiplication. So you do the same procedure that you did last week, but then you write a 4-term polynomial and split and get the GCF. So now let's try the next two examples. So for this next one, you bring it up a little bit more, I'm going to multiply a times c. So I want two numbers that multiply to give you 6 and two numbers that add to give you 7. Those two numbers would be 6 and 1. So I'm going to take my trinomial and rewrite it using the 6 and the 1. And now I'm going to split down the middle. Now on the first side, I'm going to look for my GCF. My GCF over here would be 2w. The parentheses would end up being w plus 3. So I know that if this is going to work, my other parentheses also have to be w plus 3 because this will only work if the parentheses match. So if I look at this and think, what did I have to multiply to get this? And it would just be a 1. So now my answer is the 2w plus 1, which are the two GCFs, and then w plus 3 as my other parentheses. Now for the next example, you'll notice we have something that we don't like to have. We don't like to have a be negative. So I am going to switch all the signs and make that positive. And now I'm going to think of two numbers that will multiply to give me negative 14 and add to give me negative 5. And those two numbers would be negative 7 and positive 2. So I would end up with p minus 7, p plus 2. If I do this out though, I'm going to get this, which is not what we want to have happen. We want to get this. So that negative that I took out at the beginning, I'm going to attach again. So my final answer will be this. Before we do the factor and solve ones, I'm going to show you the other method. And I'll use this example over here. You might like this lazy method better. So the lazy method, nope, I'm going to do that other problem out again. So for this lazy method, I'm going to do the a times c again. So we're always doing that. And I'm going to say, what two numbers multiply to give me 6, add to give me 7. That would be 6 and 1. I'm going to use this 2w in both parentheses. So I'm going to go right to my answer. I'm going to write 2w in both places. And then I'm going to write plus 6 and plus 1. This won't give me this if I multiply, because if I did 2w times 2w, I would get 4w squared. So you know right now that this does not multiply with this to give you that. But if I look at my two parentheses, if any of the parentheses can be scaled down, you scale it down. So this one could be scaled down by 2. So I would get w plus 3. This one can't be scaled down, so I get 2w plus 1, which is the answer that we already got. And if you multiply these two, you do get this. So the lazy way says you go right to writing your answer, and then you scale down any parentheses that you have. So if we go back to the first ones, using this lazy method, for this first one here, I would do 6 times 2 is 12, and I want them to add to negative 13. So two numbers that multiply to give me negative 12 and add to give me negative 13 would be negative 12 and negative 1. I'm going to write my two parentheses because I'm assuming I'm going right to my answer. And I'm going to put 6x as the beginning of both. I'm just using the a term, the a coefficient. And then I'm going to write minus 12 and minus 1. This parentheses can't be scaled down, but this one can. This one they can both be divided by 6. So this parentheses becomes s minus 2. And this one will stay 6x minus 1, which is the answer we got during the split or grouping method. Now you don't need to know every method, you just have to be able to do it. However, you will see most of your teachers using the grouping method, so you want to at least be familiar enough with it that you're not confused if you see them doing that out. So now if we go back down to the factor and solve ones, we're going to factor these anyway, and I'm going to use the lazy way for the first one, and then I'll use the split method for the other one. So for the lazy way, I'm looking for two numbers that multiply to give me negative 6, and add to give me 5. And those two numbers would be -6 and +1. +6 and -1, because we have +5 for our answer. Once we have these two numbers, for the lazy way, I start off by writing just whatever you have for A with your variable for your first term in each parentheses. And then I'm putting both of these in. This parentheses can't be scaled down, but this one can. They can both be divided by 2. So I'm going to get m plus 3 as one parentheses, 2m minus 1 as the other, and this equals 0. I'm asked to solve it, so if this times this equals 0, either m plus 3 equals 0, or 2m minus 1 equals 0. So now I'm going to solve it. This one will give me m equals -3. Or if I solve this one, I'm going to bring over the 1 as positive, divide by 2, and I get m equals 1/2. So those would be my two solutions, roots or zeros, that work for this. Now for the next one, I'm going to use the split method. But before I can get started, I need to make sure that everything is on one side. So I'm going to bring over that 14 as -14. Now I'm ready to do my little number puzzle. So I'm looking for two numbers that multiply to give me -42 and add to give me 19. The larger one has to be positive. So 21 and -2 multiply to give me -42 and add to give me 19. So I'm going to take my trinomial and rewrite it so that it has instead 4 terms. And now I'm going to split it down the middle. On this side, I'm going to take out the GCF, so 3 goes into both of the coefficients, and we have one C in common. So my parentheses will be C plus 7. So I like to go over and fill that in as my other parentheses because I know they have to match. So then I like to think, what does this have to be multiplied by to give me this? And it would have to be multiplied by -2. So my two parentheses for my factors would be 3c minus 2, which is the 2 GCFs. And then my other parentheses is just c plus 7. So now to solve this, I know 3c minus 2 equals 0, or c plus 7 equals 0. If I solve c plus 7 equals 0, I'm going to get -7 as one possible solution. And if I solve 3c minus 2, I would bring the 2 over as positive, divide by 3, and I would get 2/3 as my other possible solution. So now you can go to Flipgrid and try a few others, and we'll practice more with this.